given an integer array prices where price is size the price of LeetCoin. We're doing it on LeetCode. Let me reset my progress here. Now we're active here, we have no solutions. Best time to buy and sell stock. You're given an array prices where prices is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit. Yep. So it's a 2-pointer, left, right. Processor length 0 and 1, while right is less than so max profit -1, while right is less than line of prices. Then mean found. So while we're less than the length of the price, the diff is prices at right minus prices at left. If diff, or we can just call it profit. If profit is greater than max profit, or I can just do max profit is max of profit and max profit. And then if mean price, or if prices at right is less than mean price, the mean price becomes prices at right, and left becomes R. Otherwise we just keep going. To max profit. Let's go through it and see if it works. Open another window. Hiding the code. Interesting behavior from, is this LeetCode or is this i3's issue? Anyway, Scully draw. So here we have the prices 7, 1, 5, 3, 6, and 4. Left is here, right is here. So this is left, this is right. Max profit is -1. -1 max profit, and then mean price is 7. So while right is less than the length of the prices, profit is 1 minus 7, max profit is still this one. That's the maximum between -1 and -6. And then if prices on right is less than mean price, which it is, then mean price is this. So now we have the mean here, and then left becomes right, and then right comes here. We're still less than the length of the prices. Profit is right minus left, 5 minus 4, 5 minus 1, that's the max profit. So this one becomes 4. If prices right is less than price left, it's not. Otherwise we move on. Right comes here. Profit is 2. It's not greater than this. It's not the mean between the two. So yeah, the profit is 4. This is the mean. This is 1. Okay, so we keep going. Right comes here. While right is less than the length of the prices, yes. Profit is 6 minus 5. 6 minus 1, that's 5. Max profit is now 5. And prices, nope, there's no new mean. Right now comes here. Max profit is still 5. Okay, I think this makes sense. So it worked on this one, but it didn't work on this one. Output 0, -1, expected 0. I can just do profit is 0 by default. Yep. Cool. So that one is done. Let's do reverse linked list. Actually, let me do something. So given the beginning of a singly linked list, reverse the list and return the new beginning. So if I draw this, So we have a linked list. Zero, then this points to 1, this points to 2, this points to 3, this points to nothing. So this is the head. There's the head. We want to reverse it, so head is that. So we have another temporary one, or like a current. Current one is here, and then I need to keep track of the previous one while I'm iterating. So previous one is nothing at the moment. So while current is not null, is not none, we say that current's next is previous. So we make, actually no, current, we make previous be equal to current. So previous will point to current. We make current be the next one. So we make current become current.next. Then we make current.next previous, which will remove this and make this. I think that's it. And then we keep going. So now we make previous. So previous is none, current is head, while current is not none. While current is not none, we said we do temp. One second. So let me go back 1 second. So now previous is nothing, current is the head. While current is not none, we say that previous is current. Current is current.next. So previous is current. Current is current.next. And then current.next is previous. So why am I doing it on LeetCode? Current.next. No. No, because then we will lose this link. What am I doing wrong? Previous is current. Previous is none, so I need to keep track of the. So I will have another one temp here. So temp is current, move current to, so temp is current, current equals current.next. So now current comes here. Also previous is current. No. Temp. Temp.next. Previous equals temp, something like this. The return previous. So previous is none, current we have is the head. So temp is current, so here is temp. Current is current.next, so current is here. Temp.next is previous. Actually this one doesn't exist yet. So current is there, previous is none, current is head, current is not none, current temp, we make temp here, current is current.next, so it moves here, temp.next is previous, so this one is removed and becomes this, and then previous becomes temp. Previous becomes temp. So now previous is here. Current is not none. Temp is current. Temp is current. Current moves here. Temp.next is previous. Previous is temp. Okay, so I think, okay, so we're here, and this will be previous. So current will do that thing. Temp is current, so temp will be here. Current is current.next. Now current is none. Temp.next is previous. Previous is temp. We'll return previous. I think this works. Probably not. I think we have some mistake here. Let me also check the edge case. Accepted. Interesting. Just took a while. If not head, return head. Submit it. Yep. Looks good. So that's that. I want to move to something else. Let's do trees. Invert binary tree. It's been a while since I've done it, if I've ever done it. Invert binary tree. Given the root of a binary tree, invert the tree and return its root. So there's probably like an iterative way and a recursive way of doing it. So basically I want to, can I copy this image in here? Interesting. So I need to again have like a current, like a queue of nodes. So now I have node 4. Invert its children and then put them both in the queue. So then I have 2 and 7. And then I will pick up to invert its children, put them back in the queue. So I have a queue. Queue will have the root, while queue will do current is queue pop. Well, actually, I think stack is better. Stack.pop, and then here I do the revert. So I can do current dot, what is left? Current dot left, current dot right is current dot right, current dot left. Another way of doing it is you have like a temp is current dot left, then you do current dot left is current dot right, and then current dot right is temp. So if we've done the reversal, then we put it back in to add the children in the queue or in the stack. Stack.append current.left, current. Can I append more than one? Exactly one argument. Start to append current left and append current right. Return root. So we have the root. While stack is not empty, pop the root, swap, put them back in the stack, and then go to the next one. It's a pretty simple one. Non-attribute, oops, if current, if not current, continue. So this is done. Second. Okay, we've done a trees question. Now the difficult ones. Let's do tries. Implement try prefix tree. A prefix tree, also known as a try, is a tree data structure used to efficiently store and retrieve keys in a set of strings. Some applications of this data structure include autocomplete and spell checkers. Implement the prefix tree class. Okay. So I need, am I gonna do it with a tree node? Tree node. I think yes. So let's make the tree node. No. So try. Yes. So each of them basically could have an entry for each character of the alphabet. So it's not left and right. Is it value and then times 26? So we put the value in the node. And then you have the other ones. Let's try it. Self.root is tree node. Let's say it has none. Insert word. So for character in word, so current node is a root. If current node at, so let me get the index. Car index is car ord character minus lowercase English letters. So minus a, ord of a. So for lowercase a, this gives me 0. For lowercase b, gives me 1 up to 26. If car node.children at the car index is none, then we do car node at children at car index is tree node with the character as its value. And then current node. So regardless, now current node is current node dot children at car index. So now we moved to the next node. We keep doing this, keep creating new nodes if we need to, and moving to the next node. And at the end, basically we need a way to mark if this is a word, right? Self dot is word equals false. And at the end we do current node that is word equals true. Right, for each character in the word we get the index. If current node or children at that index is none, we create it, we set it. Current node is current node or children, so we move to the next one. Okay, search word. Current node is root. This is gonna fail, self.root. Self.root. Wait. No, yes, right. Car node is self.root for car in word. Is car oops. Is car keyword in Python? Oh, okay, cool. For character in word, if car index is ord of car minus ord of a, if car node dot children at car index is none, return false. Otherwise car node is equal to car node dot children at car index. We keep iterating. Keep going, and then at the end return car node dot is word. Starts with prefix, similar to this. But here we return true. Let me just run it and see what happens. It would be cool if it was right in the first try. Prefix. Imagine I get it on the first try. Decent. Yes. Nicely done. Thanks. Patting myself in the back. Backtracking. Oh, this is actually difficult. I hate these ones. The way LeetCode does it, they have like a def backtracking here. Subsets. Given an integer array, nums of unique elements, return all possible subsets, the power set. So each number can be or may not be. So you have like a result is like an empty thing. And then you do from num in nums, you do result or append num, and then you backtrack result nums. And then you take it out. Like these problems, I don't know, they need practice. Like you need to know the specific strategy, I think. So where you're building a temporary thing here. Right. You're building a temporary array. Append it. Backtrack. Pop. Something along these lines. And somewhere you add the thing. Append. So here you have 1, 2, 3. So now we're in number 1. We had 1 here. Then we backtrack. I feel like whatever I do is, I think there's no way I can figure it out. Let me just plug in my face cam. No. Just gonna watch LeetCode. I have to do it. Or I can just look at the solution. If I go here, solution. So this is the subset. If I. So this is the backtracking thing. He calls it DFS. You have an index I, you start with 0, so that you know when to like when to I+1. Yeah, when to finish, essentially. So that you can even finish with a single element. Or with any number of elements. So it starts with 0. 0 is not greater than the length. Then you append the number. You call the FS. You remove the number. You call the FS with I+1. Basically to say that you've done an operation on the array. Once you reach 3 operations, you exit, I guess. So subset you will add 1, another subset, another time you iterate you won't have the thing inside. If I do it, result is this. Subset is this. Kind of prefer to pass in the subset. Backtrack, helper, no, backtrack. I'm gonna give the subset is equal to len of nums result or append and here does is it the same thing? Backtrack 0 subset return 1 second. Yeah, result append, yeah, return result. Right. So we need to read it again. You have the result, which is gonna be the list of lists. Then you have subset arrays. You have this backtrack method. So you call backtrack with 0 and I pass in the current subset. I mean, the way he does it here is basically the same thing. I think this one makes more sense. I don't know. So you have this. Basically, which means for each element, you have to say if it's in, you gotta iterate with the element in and with the element out. Once you've done, so there are 3 elements. You gotta do that 3 times. So you append the element, the ith element, you append that in the subset, you backtrack. You go to the next element, you append it in the subset, you backtrack, you append that, Yeah. So you append that to the subset, you backtrack. So now you have this array. You add it to the result, you return. So now you have an array, you pop it, you have an array with 1, 2. You backtrack. Again, now you have I is 3. You add that into the array, to the output. So the order of output is going to be this one is first. Right, and then you have 1, 2, as expected. So now you have 1, 2. You add that in. Wait, I got lost. I hope I don't get this question. So you have the subset has 1, 2, 3, and then you pop. It has 1, 2. You pop the 2. You go to the next one. Go to the next one. Maybe it's easier if I go here. So the subset is currently empty. I call backtrack with I is 0. So this is I. It's currently 0. And an empty subset. So subset or append 1. I backtrack, so I go inside here again with I is 1. Okay. So now I is 1. I append it. I go back inside, backtrack. Now the I is 2. I append it. Backtrack. Now I is 3. I is equal to the length of nums, then result or append copy of the subset. So now I added this to the output. I want to remove this closing bracket. So I added 1, 2, 3. Okay. And then I return. So this returns. Now I pop. So I pop the 3. How do I erase? Ooh, that's pretty cool. So now I have 1, 2 in the array. Backtrack. Oh wait, and the I is 2 here. Oh, hey, Tasty. How's it going? Just doing some backtracking recursive problem here. You doing alright? We popped the 3. And we backtrack again with ice 3. Now we add 1, 2 in the output. This completes this iteration. So then we go back without the 2. Going well. I've solved yesterday's problem and already have wrote a Cardano grill generator. Nice. That's pretty nice. So what do you mean with generator? Does it now... What does it generate? Now I'm working on import-export functionality. That's pretty cool, man. It's nice to see you doing stuff. You're adding features. Do you have the code somewhere? Like on GitHub or something? Here I backtrack. And then you add 3. Yeah. I guess another way of doing it is just put it in VS Code. What is this called? Subsets. It generates 2D matrix. You need to read a bit about Cardano grill to understand what it is and how it is applicable. I have code on GitHub, but the repo is private while I didn't finish the whole app. I'm going to make it open after I finish. Nice, nice. I'll be interested to see the final result. So I guess it's you have a front-end application, or is it just like a console app with TypeScript? Yes, I use React, Vite, TypeScript for it. Nice, nice. That's a nice little project you got going. I need to find a project to work on once I finish with these things. I'm gonna start learning Next.js and make a project. How did you come up with the idea for it, for your Cardano grill? What's the inspiration? Typing. So what I can do is put breakpoints, and then that should help me print solution subsets 1, 2, 3. It's a really interesting story. I am interested. So we have this, backtrack, result is empty, subset is empty. So I is 0. We append 1 into the subset with backtrack. I is 1. We append 2 into the subset with backtrack. I is 2. We append 3 into the subset with backtrack. Now I is 3. It's the length of the array. We append it to the result. Then we return. We'll go back to this call where we have 1, 2, 3 in the subset. We pop 3 from the subset and we backtrack. So now the subset has 1, 2, the I is 2. So now I is 3. We finish with the operation here. We add the subset into the result and then we return. So now we pop 2. Now the subset is 1. No, subset is 1. We backtrack. We append 3. We backtrack. Now we add 1, 3. You pop the 3. Backtrack. Now we add the 1. Now we add the empty array. No, I is 1. I mean, I think I get it, the idea generally. You append the number, you use backtrack, you pop the number, you backtrack. Interesting. I think I'll need to come back to this one later. So we did this one. I need to do a heap question. Kth largest integer in stream. Design a class to find the kth largest integer in a stream of values, including duplicates. Heaps. I'm not very confident with heaps. Select the case K. Let's see. My wife recently has got sick. Oh, I'm sorry to hear that. Stays in the hospital for now. I sent her a paper with a message by transferring through the nurse, but one day later I found the message was intercepted and read by unwanted people. It was a private message. I was mother started to search for a way to encrypt my message the way my wife can really decrypt without any calculation and cannot be decrypted easily. Interesting. But manual encryption takes a lot of time. So there's a way to encrypt stuff. This was used in ancient China. And still, is it still used somewhere? Cardon grill use cases. Grill cryptography. Interesting. Crosswords. These pictures is definitely what I am doing. That's nice. It's cool to see like real life applications of what you're doing. In this example, a grill has 8 irregularly placed holes equal to the length of the word tangiers. The grill is placed on gridded sheet and the letter are written in the front from top to bottom. Remove the grill. Pretty cool stuff. You've completed a generator for the grill with holes. Okay. There. I want to use the app once you deploy it. I want to see how that works. What's the domain name for it? Or have you not decided yet? Yeah, send me the link once you finish it. Pretty nice. Much more interesting and exciting than these boring things. And it may be 1 or 2 evenings to complete. Wow, that's fast. I thought it will take much longer. %90 of the time I've tried to rotate and combine quarter matrices just because I'm not an algorithm guy. Okay. Let's see. Yeah, I guess you don't like algorithms that much. You prefer other things. push. Heap for nums. Kth largest. So this makes heap. Heap is priority queue. So every time we know what's the smallest element. So here I can heapify like this. I need to practice these heaps. I think heaps and backtracking is my weaknesses. And all of these things, but I'm not gonna go into these ones. So we've heapified nums, so we have a way to always get the minimum number. But what we want is the largest. So what I can do is reverse everything. Because the heap gives me the min number, the minimum. Yo, what's up, dude? Damn, I haven't seen you in a while. Oh, you're a virtual. Is that a virtual emote? Yep. You're playing Trackmania? Playing Sea of Thieves, so just not gonna lurk. Yeah, of course. Been a while. Yeah, I'm doing good, man. Doing software engineering now. How about you? How are you doing? So this gives me the n smallest. Each time the smallest element is popped. So I want the kth largest. So if I have the kth largest, if I have a min heap, if I have a min heap of length k, then this gives me what I want. Min heap of length k. So I need to make sure that my is at most length k, and then make sure heap is min heap. So if it's a min heap, I just need to is it a min heap by default? The insurance is that the smallest element is always the root. Yeah, so it is a min heap, so I don't need to do anything. It is a min heap, and then I need to ensure, so while length of nums is greater than k, I do heap pop nums. So add value heap q dot heap add val if len of heap add heap push heap item. So if length of self.nums is greater than k, heap pop that. Okay, so let's try it here. I want the kth largest. It's a min heap. Yeah, okay. Let me test it, I guess. case 3 in the example. And this is the array itself. One, two, three, three. 1, 2, 3, 3. So we have the 3 largest. And then we do bj.add yep, 3, 3, 10. And how do I get the min element? I think it's just heap at index 0. I think it's gonna work. Let me just submit it. Why did it on LeetCode? Let me run. This should be self.k. None is not valid value for the return type. Add and return self.nums at 0. Accept it. Yeah, looks good, looks good. So just want to see how the heap is, how it works. I need to read a bit. To heap data structure. Padding and popping efficiently is function used to insert. Basically it's like a tree, right? Heap data structure. So it's a heap, but you can represent it as an array. So we know what the left index and the right index of each node is. It is the index times 2 plus 1 and the index time, yeah. The index times 2 plus 1, the index times 2 plus 2. That gives us the left and right child. And then when you add a new element, you have a login operation, you put it at the end, and then you heapify up until the heap, what do you call it? Condition. The heap condition is satisfied. And what's the heap condition? The heap invariant. The heap invariant says that you're just less than your parent or more, depending if it's a min heap or a max heap. the heap invariant. A heap is a binary tree in which each node has a smaller key than its children. Yep. Each node has a smaller key, so that's the min heap. So because we wanted the kth largest, we maintained a max heap of length k. Sorry. We represented we wanted the kth largest, so we used the min heap of length k. Yeah, that makes sense. I got lost there. Min heap. Yep. Okay. Just gonna mark this as done. Move on to the next. I don't have much time until, well, I have some interviews tomorrow. So, just trying to go through as many different problems as possible. What else should we do? Graphs, maybe? Max area of islands. Yeah, I mean, this is an easy one for me, I think. I'm pretty comfortable with this. You're given a matrix grid where grid I is either 0 or 1. An island is defined as a group of ones connected horizontally or vertically. You may assume all 4 edges are surrounded by water. The area of an island is defined as the number of cells within the island to return the maximum area. So basically you just iterate through the grid. If you find the one, and you keep track of the cells that you've visited. If you find the one and it's a cell that you haven't visited, then explore the island, count how many ones there is, and then, yeah, I mean, it's pretty trivial. Clone graph. Given a node in a connected under a return a deep copy. Each node contains an integer and a list of neighbors. The graph is shown in the test cases as an adjacency list. So an adjacency list is a mapping of nodes to lists used to represent a finite graph. Each list describes the set of neighbors. For simplicity, node values are numbered 1 to n, where n is the total number of nodes in the graph. Return a deep copy of the graph. Two, 1, 3, 2. There are 3 nodes in the graph. Value 1 is connected to 2. Value 2 okay. Yeah, I think this one is just tedious to do this one. I feel like I can get more value if I do a different problem. I mean, I can just return, wait, node, I'm giving a node optional. I'm giving a node as an input. I mean, what is it? I make a new, like a BFS kind of thing. Just explore all the nodes and create copies. So I have root is node, and then I have an array or a list of nodes. So nodes is a list of currently node, while nodes is not empty, current is node.pop. It's just a tedious problem, this one. I think I'm just gonna mark it, maybe look at it later. And let's go to arrays and hashing. I feel like I should do like all of this, because it's what's most likely to come up. Group anagrams, given an array of strings, group the anagrams together. Can I hash the map? Group anagrams. Basically I need to make sure that, how do I compare that two anagrams are the same? They will have the same character count map, but then can I put that as a key in the hash map? Let me just test that. Unhashable type dict. So what do we do? What do we do? Group the anagrams. How do I group them? Just gonna look at the solution. Python. This guy sorted the word. Interesting, interesting. He makes it into a table. Count. So this guy makes a count array, and then he increments the index of the character, and then he makes that array into a table so that it can be put as a dictionary, and then he appends. I'm sure you can do it with a map. Like if I look at my previous solutions, what did I do? No, all of them have the same trick. Interesting. Okay. So it should be pretty quick to code this up. Make words instead of a map, we'll make it a table. Result is this. For C in Word, for character in the Word, result at ord of a ord of character minus ord of a plus equals 1. Return table of result. And then for S in strings, anagrams is a dictionary. Tabled word itself that make word table as if tabled word not in anagrams, then do anagrams at tabled word dot append equals a list with that word with S. Otherwise, anagrams at table word dot append S. Then return anagrams dot values. Yep, accepted. Cool. It makes sense. You can either make it a map, like a dictionary, but because dictionaries are not hashable, why is Python dictionary not hashable? This is because dictionaries only accept hashable data types as key. Only mutable objects are hashable since they have a single value that never changes. Hashing such objects always produces the same result, so they can be used as keys. So basically, because values are mutable, it's tricky because you can hash it once, put it somewhere, and then it changes value. And then when you try to hash, I don't know, you have the previous hash like changes. And then you'll never be able to retrieve them. Right, maybe we have time for one more before I need to call it a day. So we did group anagrams. Top K frequent elements. Top K frequent elements. Given an integer array nums and an integer k, return the k most frequent elements. So does this not actually use a heap? No, not a heap. Top K frequent elements. Return the k most frequent elements. You may return the answer in any order. So we know how to keep track of the count. We have a map where the key is the element and the value is the count. But then how do we make sure, how do we get the k most frequent elements? Return the k most frequent elements. I don't know, just gonna look at the solution. Solution. You have a count array. You have a count map and a frequency list. Frequency list of lists. For number in nums, count is 1 plus dot. For number and count, frequency and not count, append the number. So you end up with a count and a frequency. Alright, let me watch this.
Hey everyone, welcome back, and let's write some more LeetCode today. So today let's solve top k frequency. So this problem can actually be solved in linear time if you use the algorithm called bucket sort. So when you first think of bucket sort, this is probably what you're going to think. And in the values, we're actually going to have a list of which values have exactly this particular count. For example, 100, right? We know that 100 occurs one time. So what we're going to do is for this position 1, we're going to say, okay, this value occurs only once. 100 occurs one single time. Which value, for another value in our input array 2, we see it occurs exactly twice, right? We can count that with a hash map pretty easily twice. We see a last taken every single input value and then...
Okay, and then you go backwards. then you go backwards and yeah, okay. You make a num and count, make a list of lists that store the elements with that count. Iterate backwards in the list of lists and add elements to the result. So here I'm just breaking it down into 3 steps. And the reason this works is you have a list of numbers of length n. At most, like all of the elements will be the same value, so you have a frequency list of length n. So I'm just gonna do this quickly. So make a dictionary. Num count is the dictionary for num in nums. Num count of num plus is equal to 1 plus num count dot get num count dot get num 0. So we're adding 1 to that. Make a list of lists that store the elements, like frequency list. For I in range len of nums, and then for num count in num count dot items frequency list at count dot append num. And then iterate backwards on the list. Result is an empty list. For I in range len of nums -1 up to -1, right? Pretty sure. Up to 0. Why is it up to 0? Because it's inclusive, right? I mean, it's exclusive. This one is inclusive. The second one is exclusive. One second, let me try. For I in range from 10 to 0, print I. Yeah, it doesn't go to 0. So I think it should be -1 here. if frequency list at I, then we do result dot append frequency list at I -1, and then frequency list and the frequency list. I mean, how many are in here? So we found a list which is not empty. Do we just do a while loop? You just add all of them. So I'll do for num in frequency list result or append, and then if length of result is equal to k, return result, something like this. Result to append frequency list num. For num in frequency no. For num in frequency list I. List index out of bounds, frequency list count. What? +1. Again, another off by 1 error. Case 2, wrong. Is this why? Nope. Nums is a list with one element. So num count is a dictionary for num and nums. 1 plus 0, which is 1. So we have 1, 1. Frequency list for I in range that here is error. No, that's not the error. Where is the issue? no idea why. Time to debug top K frequent elements. Three, four, seven. Damn, I had made this solution with a heap here. Top K frequent 1, 1. Debug this. Frequency list has one more one empty list. Okay. Is that why? Frequency list has two elements. One is an empty list, the other is the list with one element in it. I'm so screwed. Hopefully I will do well tomorrow. So frequency list has these two elements. Oh, I'm iterating through it. I should be iterating through frequency list. That's the issue. No, it should work. Yeah, let's go. If I submit, yep, works finally. No, I'm interested in this solution that I have here with a heap. I don't know if I came up with this myself or if I saw this somewhere. Probably saw it somewhere. So you have a heap, and then you hit push, basically the same principle. You have a heap, min heap, and then you add the count as the like a table with a count and the num, and then it makes it a min heap, and then yeah, same idea as the other problem. Okay, I'm feeling quite good for tomorrow. We'll see how it goes. Hope it goes well. I'm gonna let you know. But yeah, I think I'm gonna call it a day for today. Yeah, thanks for hanging out, Tasty. How is it going with your thing? I'm looking forward to testing it. The grill generator. But yeah, wish me luck. I'll see you next time. Have a good one.